Hello everyone. Today we are going to discuss about the chemistry involved in a crime scene investigation. The word forensic comes from the Latin adjective forensis, means of or before the forum. It's a synonym for legal or related to courts. There are mainly four types of forensic laboratories: biology, chemistry, DNA, and drugs. The chemistry unit is dedicated to some specific tasks, namely blood and urine test for alcohol, drugs and poisoning test, test of synthetic materials, test of dyes and stains. Testing of sample includes testing of two types of compounds, organic compounds and inorganic compounds. The tests on organic compounds are based on carbon and it is mainly found in living things. The tests on the inorganic compounds are based on other elements. There are many techniques which determine the chemical composition of evidences containing inorganic compounds which helps in carrying out the investigation. There are two types of samples, biological and non-biological. The examples of both categories are shown. The next topic is fingerprint detection. There are mainly three types of fingerprints: patent print, latent print, and plastic print. The name given to fingerprints on hard surfaces which are visible are called patent print. These can be photographed without the aid of chemicals to improve visibility. Latent print: the fingerprints made by the body's oil and sweat remaining on hard surfaces after contact. Not visible, so various techniques are used to make them visible. Plastic print: three-dimensional fingerprints left on soft surfaces such as wax or wet paint, already visible so can be photographed without the use of additional techniques. Different ways to find the latent: chemical developers, vacuum metal deposition, fingerprint powders, and cyanoacrylate fuming. Chemical developers is a method by which we can make a fingerprint glow by using some chemical reactions. Ninhydrin reacts with amino acids in sweat to produce a purple compound. Other developers, such as DFO, make fingerprints glow in certain colors of light. Decomposition is the process which generally involves layers of gold and zinc left on surface under vacuum condition to visualize latent prints. The usual combination is gold followed by zinc. It works because the zinc doesn't deposit on fatty regions. Cyanoacrylate fuming. Surfaces where latent fingerprints may be found can be exposed to cyanoacrylate fumes to make them visible. Cyanoacrylates are used in superglue and polymerized on contact with fingerprint residue, making a white 3D matrix. Fingerprint powders. A range of powders of varying compositions, but commonly consisting of a pigment and a binder. When brushed on a surface, the powder clings to the moist and oily residue left by fingerprints, visualizing them. The image on the slide displays the commonly used pigments and all the consisting elements of it. These includes aluminium, zinc, copper powders, and colloidal carbon. The widely used variety of binders are also shown in the slide, which includes rosin, gum arabic, iron powder, and lycopodium. The next topic of our presentation is the use of chemistry in depicting the blood in crime scenes. Luminol. Luminol is the substance that reacts with human traces to help detectives solve crime. Its chemical name is 5-amino 2,3-dihydro-1,4-phthalazine. Investigators spray a solution of luminol onto the surface, which reveals light blue outline of traces of blood, feces, urine, and bleach. The figure shown in the slide represents the structure of luminol. How does luminol work? It works on the process of chemiluminescence and it involves the production of light from a chemical reaction. Here are two different chemical react together and forms a high energy intermediate which on breaking down releases blue light. To exhibit its luminescence, the luminol must first be activated. Usually the activator is a solution of hydrogen peroxide and sodium hydroxide in water. When luminol reacts with the hydroxide ion, a dianion is formed, and a dianion is an anion with two negative charges. The most important step in this reaction is the oxidation of luminol with oxygen, which results in the excited state dianion. The oxygen is usually formed from hydrogen peroxide, that is, added to the reaction solution. In an aqueous solution, hydrogen peroxide can decompose to produce oxygen. The figure shown in the slides depicts the reaction to give the blue light. To get the traces of blood, the investigator prepares the solution of luminol and sodium hydroxide and hydrogen peroxide. Then he sprays it on the area under investigation. Iron present in the blood catalyzes the reaction, which produces the luminescence. But the glow lasts for about 30 seconds, and detecting the glow requires a fairly dark room. So, this was all about the use of various chemical compounds used on the crime scene. Throughout the video, we try to give you a brief insight of the various processes that takes place at the crime scene, even though the video covered only some basic concepts in this field. We hope you like the content of the video. Thank you.